overnighter. Imagine a time before history began, a world without cities, without electricity, without the eternal glow of artificial lights. When our ancestors looked up at the night sky, they saw a living, three-dimensional jewel box, and stretching across the heavens, cutting through the darkness, was a shimmering arch made of light. For thousands of years, humanity asked, "What is this?" The ancient Greeks called it Galaxius Kyklos, the Milky Circle, believing it was milk spilled by a goddess. The Romans named it Via Lactea. In the east, they saw a silver river separating celestial lovers. In the Kalahari Desert, it was the backbone of night. Every culture projected its own stories onto this band of light. But none could imagine the true magnitude of what they were seeing. They thought it was a cloud or a divine sign. No one knew that this whiteness was actually the combined light of billions of suns. The secret remained locked until 1610. That year, Galileo Galilei turned his primitive telescope toward the Milky Band. What he saw changed everything. That misty cloud was not a cloud at all. It was composed of countless stars packed so tightly that the naked eye blurred them into a single stream. Humanity realized for the first time that our home was crowded. For centuries, we thought this galaxy was the entire universe. We were like a tribe on an isolated island, mistaking our island for the whole world. It wasn't until the 1920s that Edwin Hubble showed us the truth. The Milky Way is just one of billions of galaxies drifting in an infinite sea. We are just a grain of sand in the cosmic ocean. Today we know the numbers, but they are hard to grasp. Our galaxy is a barred spiral, a city of stars 100,000 light years across. Light travels at 300,000 kilometers per second. It can circle the Earth 7 times in a heartbeat. Yet, for a beam of light to travel from one end of our galaxy to the other, it would take 100,000 years. All of human history is just a blink of an eye compared to that journey. Inside this city, there are up to 400 billion stars. Each one is a sun. Each one is a potential home for other worlds. If you looked at a new star every second, it would take you thousands of years to see them all. And this city is moving. It rotates with majesty. But the galaxy is so vast that our sun takes 280 million years to complete just one lap. We call this a cosmic year. The last time we were in this position, dinosaurs were just appearing. Flowers did not exist yet. And in the next lap, who knows who will be here? To look at the Milky Way is to look at time. Every atom in your body, the iron in your blood, the calcium in your bones, was forged in the hearts of stars that died long ago within this galaxy. We are stardust. The journey we are about to begin is not just a tour of space. It is a homecoming. Fasten your seatbelts. We are leaving Earth. Our journey to the source of the Silver River begins now.
the architecture of a giant. To truly know our home, we must step outside of it. We must send our imagination hundreds of thousands of light years into the void and look back. If we could view the Milky Way from the side, floating in the deep silence of intergalactic space, what would we see? It would not look like the perfect sphere of a planet. It would look remarkably fragile. It resembles two fried eggs stuck back to back, flat and thin at the edges, but bulging significantly in the center. This is the classic profile of a spiral galaxy. But we are not just any spiral. We are a barred spiral. This colossal city of stars is a masterpiece of cosmic engineering, divided into three distinct neighborhoods. The bulge, the disk, and the halo each represents a different epoch in time, and each tells a different story of survival. Let us begin our journey at the heart, the galactic bulge located at the very center. This is the bustling downtown of our city. It is a dense, chaotic, and blindingly bright ball of stars stretching about 10,000 light years across, but it is not a sphere. It is shaped like a peanut or a rectangular bar. This bar structure acts like a cosmic funnel channeling gas into the center to feed the sleeping giant that lies there. The stars here are mostly old red giants, the ancient citizens of the galaxy. They are packed so tightly together that if you lived on a planet inside the bulge, you would never know true darkness. The night sky would be ablaze with the light of 1,000,000 suns, visible even in the daytime. It is a place of immense energy, radiation, and ancient violence, far too dangerous for life as we know it. Extending outward from this chaotic center is the galactic disk. This is the suburbs. This is where we live. The disk is a thin, flat plane of rotating stars, gas, and dust. While the galaxy is 100,000 light years wide, the disk itself is incredibly thin, only about 1,000 light years deep. If the Milky Way were the size of a pizza, the disk would be thinner than the crust. Unlike the red and dying center, the disk is blue and alive. It is the galaxy's active factory. It is filled with massive molecular clouds, the raw materials for new solar systems. This is where the action is. But the disk is not a solid plate. It is broken into beautiful swirling structures we call spiral arms. The Milky Way has 4 major arms: the Scutum Centaurus arm, the Perseus arm, and the Lesser Sagittarius and Norma arms. Our sun is located in a minor bridge, a quiet spur known as the Orion arm. We are situated in the Goldilocks zone of the galaxy, not too close to the deadly radiation of the center, and not too far out in the cold edge. But what are these arms? They are not fixed structures like the spokes of a wheel. Scientists believe they are density waves. Think of a traffic jam on a highway. Cars slow down as they enter the jam, creating a dense cluster, and then speed up as they leave. The jam itself stays in one place while the cars move through it. Similarly, stars slow down as they enter the spiral arms, lighting them up with their brilliance, and then speed up as they exit. These arms are the rhythmic heartbeat of the galaxy, compressing gas to birth new stars. Finally, surrounding the entire galaxy like a silent ghost is the halo. You cannot see it with your naked eye, but it is there. It is a vast spherical shell that envelops the main disk. Here we find the globular clusters, tight groups of millions of stars that are incredibly old, almost as old as the universe itself. They roam the halo like ancient wanderers, the last survivors of the galaxy's formation. But the halo's true secret lies in what is invisible. The visible galaxy, or the stars, gas and dust we can see, makes up only a tiny fraction of the total mass. The rest is dark matter. This mysterious invisible substance forms a massive scaffold, a halo that extends far beyond the visible stars. It makes up nearly 90% of the galaxy's mass. It acts as the gravitational glue. The Milky Way rotates so fast that by all laws of physics, it should tear itself apart. Stars should be flung into the void like water from a spinning tire, but they don't. Dark matter holds them in. It holds us in. So here is our reality. We live on a razor-thin disk tucked inside a spiral wave, rotating around a chaotic bar of ancient stars, all held safely inside an invisible sphere of dark matter. It is a structure of impossible elegance, built over 13 billion years.
Stellar nurseries. If the skeletal structure of the galaxy is impressive, its internal organs are simply beautiful. As we drift through the spiral arms, we are not traveling through empty space. We are entering the galaxy's art gallery. We are entering the nebulas. The word nebula comes from the Latin word for cloud. And that is exactly what they are. Colossal clouds of gas and dust floating in the interstellar medium. But these are not like the fluffy white clouds of Earth. These are the largest structures in the galaxy, some stretching hundreds of light years across. They are the cosmic laboratories where the universe conducts its most important experiment, the creation of stars. To understand how a star is born, we must look into the darkest, coldest places. Paradoxically, the fires of the stars are forged in the freezing cold. These regions are called giant molecular clouds. Imagine a cloud so massive that it contains enough material to build 1 million suns. It is composed mostly of hydrogen, the simplest element, mixed with traces of heavier dust, carbon, silicon, and iron. It is dark, opaque, and incredibly cold, hovering just a few degrees above absolute zero. For millions of years, this dark cloud just floats, balanced in a delicate equilibrium. But then something disturbs the peace. Perhaps a nearby supernova explodes, sending a shockwave through the cloud. Or perhaps the cloud passes through a dense spiral arm. The balance is broken. Gravity wakes up. Gravity begins to pull the dust and gas inward. It is a slow, relentless collapse. As the cloud shrinks, it spins. As it spins, it flattens. And as it compresses, the center begins to heat up. Deep inside this dark cocoon, a protostar forms. It is an angry, violent infant star thrashing against its shell. It is not yet a star, it is a pressure cooker waiting to explode. The temperature at the core rises thousands of degrees, then millions. And then the magic moment arrives when the core temperature hits 10 million degrees Celsius. A nuclear fire ignites hydrogen atoms smashed together to create helium, releasing a burst of pure energy fusion. A shockwave blasts outward, blowing away the remaining cocoon of dust. A beam of light pierces the darkness. A new star is born. It joins the galactic city, adding its light to the billions of others. We can see this drama unfolding right now in one of the most famous images ever taken. The pillars of creation in the Eagle Nebula. These are not stone pillars. They are towering mountains of gas and dust light years high. They look solid, but they are ethereal. The powerful ultraviolet radiation from young, massive stars nearby is eroding them, sculpting them like sandcastles in a cosmic wind. Inside those pillars, hidden from view, hundreds of new solar systems are currently forming. Or look at the Orion Nebula, located just below the belt of the Hunter. It looks like a fuzzy star to the naked eye, but through a telescope it is a chaotic glowing cavern. It is the nearest large stellar nursery to Earth. Here, 4 massive stars known as the trapezium act like floodlights, illuminating the entire cavern with their brilliance. But the birth of a star is rarely a solitary event. The leftover dust and gas that wasn't used to make the star forms a spinning disk around the equator. This is the protoplanetary disk. Inside this disk, dust grains stick together to form pebbles. Pebbles become rocks. Rocks become boulders, and boulders become planets. This is exactly how our solar system was born, 4.6 billion years ago. We are the debris, the leftovers of a solar nebula. Every sip of water you drink, every breath of air you take was once part of a cloud just like the one in Orion. These nebulas are not just pretty pictures. They are our origins. They remind us that the galaxy is not a static museum of dead rocks. It is a garden. It lives, it dies, and it is constantly replanting itself. But a star's life is not infinite. Just as they are born from dust, they will eventually return to dust. And some stars, the true giants of the galaxy, live fast and die young, in the most spectacular way possible. Of stars. We leave the nebulas behind. The nursery is closed. The star is now alone in the void. To the naked eye, looking up from a backyard in the suburbs, all stars look like white pinpoints of light. But if you were to travel closer, you would see a spectacular diversity. Stars are not all the same. They have personalities, they have colors, and most importantly, they have destinies determined by a single factor: mass. Once a star ignites, it enters a phase called the main sequence. This is the prime of a star's life. It is a stable, long, and peaceful period. Think
Think of it as adulthood for 90% of a star's life. It will stay in this phase, locked in an eternal tug of war. On one side, gravity is trying to crush the star inward, wanting to collapse it into a point. On the other side, nuclear fusion in the core is pushing outward, trying to blow the star apart. When these two titanic forces are perfectly balanced, a star shines. This balance is called hydrostatic equilibrium. But not all equilibriums are created equal. The galaxy is populated by a rainbow of stars, classified by letters O, B, F, G, K, M. Oh, be a fine girl, kiss me. This is the mnemonic astronomers use to remember them. At the top of the food chain, we have the O and B type stars, the blue giants. Imagine a star 50 times the mass of our sun. These are the rock stars of the galaxy. They are incredibly hot, burning at surface temperatures of 30,000 degrees or more. Because they are so hot, they shine with a piercing blue or white light. But there is a price for this brilliance. These stars are cosmic gluttons. They consume their hydrogen fuel at a voracious rate. They are like high-performance sports cars with tiny gas tanks. They live fast and they die young. A massive blue giant might live only for a few million years, a blink of an eye in cosmic time. They appear, they dazzle the galaxy, and they vanish. Moving down the scale, we find the G-type stars, the yellow dwarfs. This is our sun. These are the mediators of the galaxy, not too hot, not too cold, not too big, not too small. They burn at a modest 500 degrees Celsius, emitting a stable yellow-white light. Because they burn their fuel more conservatively, they live much longer. Our sun has been burning for 4.6 billion years, and it has enough fuel to keep going for another 5 billion. It is this stability, this Goldilocks quality, that allows life to evolve. It takes billions of years for biology to go from a single cell to a civilization. You need a patient star for that. You need a yellow star. Finally, at the bottom of the sequence we have the M-type stars, the red dwarfs. These are the most common stars in the Milky Way. If you took a random scoop of stars from the galaxy, 75% of them would be red dwarfs. They are small. Some are barely larger than the planet Jupiter. They are cool, glowing with a dim red ember's light. They are so dim that you cannot see a single one of them with the naked eye from Earth. Even though our nearest neighbor, Proxima Centauri, is one of them. But do not underestimate them. The red dwarfs are the tortoises of the universe. Because they are small, they burn their fuel with incredible efficiency. They sip their hydrogen while a blue giant dies in millions of years. And our sun dies in billions. A red dwarf can live for trillions of years. Long after our sun has died, long after the Milky Way has collided with Andromeda, these little red stars will still be shining. They will be the last lights to go out in the universe. So when you look at the night sky, you are looking at a population of diverse ages and temperaments.
You are seeing the blue youth burning with reckless abandon. You are seeing the yellow middle-aged steady and reliable. And you are seeing the unseen red elders, silently watching the eons pass. But no matter how efficient a star is, the laws of physics are absolute. Nothing lasts forever. Every star has a fuel tank, and one day, that gauge will hit empty. What happens when the fire goes out? What happens when gravity, which has been waiting patiently for millions of years, finally wins the tug of war? The answer depends on the star. For some, it is a quiet fade into the night. For others, it is the most violent explosion in nature.
The death of stars. Everything that lives must die. Even the stars. For billions of years, a star fights a heroic battle against its own gravity. It burns hydrogen to keep the darkness at bay. But the laws of physics are unforgiving. Eventually, the fuel runs out. The engine sputters. And when the fire stops, gravity, which has been waiting patiently since the star was born, finally wins the war. But how a star dies depends entirely on how it lived. Let us look at the fate of a star like our sun. A medium-sized, yellow star. In about 5 billion years, the hydrogen in the sun's core will be exhausted. The core will shrink under gravity, getting hotter and hotter. This heat will push the outer layers of the star outward. The sun will begin to swell. It will grow larger and cooler and redder. It will become a red giant. It will swallow Mercury. It will swallow Venus. And it will likely expand all the way to Earth's orbit. The blue skies of Earth will vanish. The oceans will boil away. And the mountains will melt. Our planet will be bathed in the fiery atmosphere of its dying parent. But this death is gentle. The red giant does not explode. It simply exhales. It sheds its outer layers into space, like a snake shedding its skin. These layers of glowing gas drift away, creating one of the most beautiful objects in the universe, a planetary nebula. Despite the name, these have nothing to do with planets. They are the colorful ghosts of dead suns. Deep inside this colorful cloud, the naked core of the star remains. A white dwarf. It is a diamond the size of Earth, glowing with residual heat, slowly fading into blackness over trillions of years. This is the quiet, dignified and awaiting our solar system. But for the massive stars, the blue giants, death is not quiet. It is a catastrophe. A massive star is a pressure cooker. Because because it has so much gravity. It can fuse heavier and heavier elements. It burns hydrogen into helium, then helium into carbon, then neon, oxygen, silicon, inside a dying massive star. The structure looks like an onion, layers of different elements burning furiously. But there is a dead end. Iron is the ash of stellar fire. You cannot fuse iron to create energy. Fusing iron consumes energy. When the star starts creating iron in its core, the clock starts ticking. It has seconds left to live. The iron core grows. It becomes heavy. It cannot produce the outward pressure to hold back gravity. Suddenly, in a fraction of a second, the core collapses. The iron ball, the size of Earth, collapses down to the size of a city. The outer layers of the star rush inward at 25%. The speed of light, slamming into this super hard core. The supernova, they bounce off the core with unimaginable violence. The star tears itself apart. For a few weeks, a single supernova can outshine the entire Milky Way Galaxy. It releases more energy in a few seconds than our sun will release in its entire 10 billion year lifetime. This explosion is not just a spectacle. It is the reason you exist. Think about the gold ring on your finger, the silver in your electronics, the uranium in our power plants, the iodine in your thyroid. None of these heavy elements were made in the Big Bang. They were not made in normal stars. They were forged in the fires of a supernova. The extreme heat and pressure of the explosion fuse atoms together to create the heavy elements of the periodic table. Then, the explosion scatters this enriched dust across the galaxy. This dust mixes with new clouds. It becomes part of new nebulas. And millions of years later, gravity pulls that dust together to form a new star. A new planet's Earth is made of this debris. You are made of this debris. When a massive star dies, it seeds the galaxy with the ingredients for life. It is the ultimate cosmic recycling. We are, quite literally, the children of the dead giants. But what gets left behind after the explosion? The outer layers are gone, scattered to the winds. But the core, that crushed city-sized ball of matter, it survives. But it has transformed into something terrifying.
The cosmic graveyard. The explosion is over. The supernova has torn the star apart and scattered its outer layers into the void. The light fades. The dust settles. But something remains. In the center of the debris, a phantom survives. We have entered the realm of the undead. We are looking at a neutron star.
To understand this object, you must break the laws of common sense. Imagine taking our sun, a ball of plasma 1,000,000 kilometers wide, and crushing it, squeezing it down until it is the size of a single city. Imagine the entire mass of the sun packed inside the limits of Manhattan or London. This is a neutron star. A ball of matter only 20 kilometers wide, containing more mass than 500,000 Earths. The density is terrifying. The pressure is so extreme that atoms themselves collapse. Electrons are smashed into protons to become neutrons, hence the name. If you could travel there with a spoon and scoop up just 1 teaspoon of neutron star matter, that single teaspoon would weigh 1 billion tons. That is the weight of Mount Everest compressed into a spoon. If you dropped it on Earth, it wouldn't just sit on the ground. It would punch through the crust and sink straight to the core like a bullet through wet paper. Gravity here is the ruler. It is 100 billion times stronger than on Earth. The surface is smoother than a billiard ball. Any mountain would be no higher than a few millimeters, yet climbing it would require more energy than climbing Everest. If you were to drop a marshmallow onto the surface from a height of just 1 meter, it would hit with the force of a nuclear bomb. But these dead stars do not sit still, they spin. When a massive star collapses, it conserves its angular momentum. Just like an ice skater pulling in their arms to spin faster, the core accelerates. Some of these city-sized stars spin hundreds of times per second. Imagine a sphere the mass of the sun spinning faster than a kitchen blender. This rapid spin creates one of astronomy's most useful tools. The pulsar neutron stars have powerful magnetic fields that funnel beams of radiation out of their poles. Because the star spins, these beams sweep across the universe like a lighthouse, flash, flash, flash. From Earth, we see a pulse of light every time the beam points at us. They are the most precise clocks in the cosmos. When first discovered in 1967 by Jocelyn Bell Burnell, the signal was so regular, beep, 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 that astronomers thought it might be aliens. They jokingly named it LGM-1 for Little Green Men. But it wasn't aliens. It was the heartbeat of a dead star. But there is a monster even scarier than a normal pulsar. Occasionally, a neutron star is born with a magnetic field quadrillions of times stronger than Earth's. These are magnetars. They are the strongest magnets in the universe. If a magnetar were to fly through our solar system and stop halfway to the moon, its magnetic field would wipe every credit card on Earth. But that would be the least of our problems at that distance. The field would be so intense it would dissolve the iron in your blood. It would distort the atoms in your body into needles you would simply vaporize. Sometimes, the crust of a magnetar cracks. This is a star quake. A quake on a magnetar releases more energy in 1/10 of a second than our sun releases in 100,000 years. An invisible blast of gamma rays that can sterilize anything in its path. So, is this the end? Is the neutron star the final gravestone? Not always, sometimes. Two of these dead stars find each other. They orbit, spiraling closer, dancing a dance of death. Eventually, they collide. A kilonova, this is not just an explosion. It is an alchemy factory. The collision is so violent that it rips apart neutrons and reassembles them into heavy elements. Do you have gold jewelry? Or platinum? That gold was not made in the Big Bang. It wasn't even made in a supernova. It was created in the violent collision of two city-sized dead stars. The universe had to destroy two suns to create the gold in your wedding ring. We call this the cosmic graveyard, but it is buzzing, flashing, and crashing. It is where matter is pushed to the absolute limits of physics. But even a neutron star is not the ultimate limit. There is a fate even darker when a star is too massive. Gravity does not stop. It keeps crushing, the surface collapses. The neutrons collapse. The light collapses. The door closes. We are approaching the monster in the dark.
The heart of darkness. We have reached the limit of physics when a dying star is too massive. More than 3 times the mass of our sun. Even the neutrons cannot hold back the crushing force of gravity. The collapse does not stop at a city-sized ball. It continues. The star shrinks smaller and smaller. It becomes smaller than an atom, smaller than a proton. And then it vanishes from our reality. It leaves behind a puncture in the fabric of space-time, a bottomless pit, a black hole. It is the most terrifying object in the universe, yet it is arguably the most simple. A black hole is not a solid object like a planet. It is a place where gravity is so strong that the escape velocity exceeds the speed of light. Since nothing can travel faster than light, nothing can escape. Not matter, not radio waves, not even light itself. The boundary of this pit is called the event horizon. This is the point of no return. It is not a physical surface you can touch. Think of it as the edge of a waterfall. If you are swimming in a river above a waterfall, you can swim away if you are strong enough. But once you cross the edge, no matter how fast you swim, the water carries you down. At the event horizon, space itself is falling inward faster than light. What would happen if you fell in? As you approach, you would experience a nightmare called spaghettification. Gravity gets stronger the closer you get. If you fall feet first, the gravitational pull on your feet would be millions of times stronger than the pull on your head. This difference would stretch your body like a piece of dough. Your bones would snap, your muscles would tear, and you would be drawn out into a long, thin noodle of atoms streaming into the darkness. But before you die, you would see something incredible. Because of the immense gravity, time itself slows down.
If you look back at the universe behind you, you would see time speeding up. You might see millions of years of galactic history flash by in a few seconds. You would watch the future of the universe unfold before you vanish forever. And at the center, the singularity, a single point of infinite density. Here, our understanding of the universe breaks down. The laws of physics result in error. Time stops. Space means nothing. It is the ultimate mystery. We are not just telling ghost stories. We know they are real because we have one in our own backyard. Let's travel 26,000 light years from Earth, back to the very center of the Milky Way, past the dust, past the crowded clusters. There, sitting in the silence, is a monster. We call it Sagittarius A. It is a supermassive black hole. It contains the mass of 4 million suns crushed into a space no wider than the orbit of Mercury. How do we know it's there if we can't see it? We watch the ghosts dancing around it. Astronomers have tracked a group of stars called the S-stars at the galactic center. One of them, a star named S2, whips around an invisible point at incredible speeds. Up to 5,000 kilometers per second. It drifts slowly, then suddenly whips around a sharp corner and speeds away, like a comet swinging around the sun. But there is no sun there. There is only darkness. The only thing that could swing a massive star around like a toy is a supermassive black hole. But do not panic, Sagittarius A's is a sleeping giant. It is currently on a diet. It is not devouring stars right now. It is just sipping on wisps of gas. It is quiet, however. Millions of years ago, it may have been a raging beast blasting jets of radiation thousands of light years into space. And one day, if a star wanders too close, it will wake up again. The star will be ripped apart, forming a glowing disk of death before being swallowed whole. This monster is dangerous. Yes, but it is also necessary. Just as the sun holds the planets in orbit, this supermassive black hole acts as the gravitational anchor for the center of our galaxy. It is the dark heart that beats in the middle of the city. But gravity alone is not enough to hold the entire galaxy together. As we move away from the center, we realize something is wrong. The math doesn't add up. The galaxy is spinning too fast. By all rights, it should fly apart. There is something else out there, something invisible, something massive. We are leaving the visible world behind completely.
The invisible scaffold.
We have explored the blazing stars, the colorful nebulas, and the terrifying black holes. We think we know what the Milky Way is made of. We think we understand the ground we stand on. But we are wrong. Everything we have seen so far, every star in the night sky, every cloud of gas, every planet, every atom in your body, and even the black holes makes up only a tiny fraction of the galaxy's true mass. The reality is humbling. The visible universe is just the icing on the cake. The cake itself is invisible. We are merely the foam floating on a deep, dark ocean. The discovery of this phantom began in the 1970s with a brilliant astronomer named Vera Rubin. She was studying the rotation of spiral galaxies and expected them to behave like our solar system. In the solar system, the rules are simple. Objects close to the massive center move fast, and objects far away move slowly. Mercury whips around the sun at 47 kms far out in the cold dark. Neptune moves lazily at only 5 kms. If Neptune tried to move as fast as Mercury, the sun's gravity wouldn't be able to hold it. It would be flung out into interstellar space. Rubin expected to see the same logic in galaxies. Since the density of stars is highest in the center, the outer stars should be drifting slowly. But when she looked at the data, she saw something impossible. The stars on the frozen outer edge of the spiral arms were zooming around just as fast, sometimes even faster, than the stars near the center. According to the laws of physics, this shouldn't happen. The Milky Way is spinning so fast that the gravity of the visible stars is nowhere near strong enough to hold it together. It should tear itself apart. Stars should be flying off into the void like water droplets from a spinning tire. But the galaxy holds its stays intact. Rubin realized that there must be something else there. Something we cannot see. Something incredibly massive providing the extra gravity needed to grip these fast-moving stars. We call it dark matter. Dark does not mean it is a shadow or black dust. It means it is transparent. It is a ghost. Dark matter is unlike anything you have ever experienced. It is non-baryonic, meaning it is not made of atoms. It is not protons, neutrons, or electrons. Light goes right through it. It does not reflect, absorb, or emit light. If you were holding a chunk of dark matter in your hand right now, you wouldn't see it. You wouldn't feel it. It would pass right through your flesh, through the floor, and through the earth without hitting a single atom. It interacts with nothing except gravity. We now know that the Milky Way disk, that beautiful spiral we see in pictures, is just the visible spine of a much larger creature. Imagine the galaxy as a flat frisbee. Now imagine that frisbee floating inside a gigantic invisible beach ball. That beach ball is the dark matter halo. This invisible sphere extends far beyond the visible stars, reaching out 300,000 light years into the void. It is the scaffold of the galaxy, the skeleton. The visible stars are just glowing Christmas lights hanging on this invisible tree. But how do we know it's there if we can't see it? We use the universe itself as a lens. When we look at distant galaxies behind massive clusters, we see their light bending and warping. Gravity bends light. But the bending is far too extreme for the visible stars to account for. There is an invisible mass acting like a giant glass lens, magnifying the background. This gravitational lensing is the fingerprint of the ghost. calculations tell us that dark matter makes up about 85% of the matter in the universe. Let that sink in. The stars, the planets, the oceans, your house, your family. All of normal matter is the minority. We are the rare, exotic exceptions. The universe is mostly made of stuff we do not understand. Without this ghost, we would not be here. In the early universe, it was dark matter that clumped together first. It formed a vast cosmic web, a network of invisible filaments stretching across the dark. Its gravity pulled in the normal gas, creating the pools where the first galaxies could form without dark matter. The gas would have remained spread out forever. No stars, no planets, no life. It is the invisible guardian that built our home. So as we look at the Milky Way tonight, we must change our perspective. We are not looking at a city of stars floating in emptiness. We are looking at a massive structure of invisible matter highlighted by a few sprinkling lights that we call suns. And we are not alone in this dark ocean. Our invisible sphere is drifting toward another invisible sphere. A neighbor is watching us from the dark. A neighbor that is bigger, brighter, and coming closer every second.
Neighborhood. We have spent our journey exploring the interior of our home. We have walked its spiral halls, peered into its dark basements, and marveled at its invisible foundations. But now, we must ask, is our house alone on the hill? For a long time, humanity thought the answer was yes. We thought the Milky Way was an island universe drifting in solitary confinement in an endless void. But we were wrong. We are not an island. We are part of an archipelago. We live in a busy, chaotic, and gravitationally bound family known as the local group. This cosmic neighborhood spans about 10 million light years and contains over 54 distinct galaxies. Most of them are small, quiet dwarf galaxies hovering around the giants like moths circling a flame. But there are 3 monarchs ruling this kingdom. The third largest is the Triangulum Galaxy, a beautiful shy spiral. The second largest, or perhaps the most massive, depending on the dark matter, is us, the Milky Way, and the undisputed king of the hill, the largest in physical size, is Andromeda. Let's look closer at our own front yard first, orbiting around the Milky Way, trapped by our massive dark matter halo are dozens of satellite galaxies. The most famous of these are the large and small Magellanic Clouds. If you travel to the southern hemisphere, to Chile, Australia, or South Africa, and look up on a clear, moonless night, you can see them with your naked eye. They look like 2 torn pieces of the Milky Way that have broken off and drifted away. Named after the explorer Ferdinand Magellan, who used them for celestial navigation. These are irregular dwarf galaxies. They are vibrant, chaotic, and bursting with new star formation.
But their relationship with the Milky Way is not peaceful. It is abusive. The massive gravity of our galaxy is slowly tearing them apart. As they orbit us, we strip gas and stars from them, create a massive bridge of hydrogen called the Magellanic Stream. The stream trails behind them like the wake of a ship, falling onto our galaxy to feed our own star formation. We are slowly stealing their fuel.
And we have done worse, hidden behind the thick dust of our own galactic disk. Astronomers recently discovered a corpse, the Sagittarius dwarf galaxy. This small galaxy made the mistake of getting too close. The Milky Way captured it and is currently in the process of eating it alive. It has been stretched out into a long loop of stars that wraps around our galaxy like a ribbon. Every time it passes through our disk, we rip more stars away from it. This teaches us a dark truth. Galaxies grow by being cannibals. The majestic size of the Milky Way was built by swallowing smaller neighbors over billions of years. We are a graveyard of eaten galaxies.
But if we are the bully of the neighborhood, there is someone else out there who is bigger than us. Look 2.5 million light years into the darkness, there lies Andromeda. It is a terrifyingly beautiful sight. It contains 1 trillion stars, more than double the number in the Milky Way. Its spiral arms are wider, its central bulge is brighter. If our eyes were sensitive enough to see its full width in the night sky, it would appear 6 times wider than the full moon. It hangs over us like a giant watching from the dark.
Andromeda is unique for one very special reason. In an expanding universe where almost every other galaxy is rushing away from us, Andromeda is different. It is bathed in a ghostly blue light blue shift. This means it is moving towards us while the rest of the universe runs away. Andromeda is rushing at us at 100 kilometers per second. Gravity has won the battle against the expansion of the universe here. The invisible dark matter halos of our 2 galaxies have locked onto each other. We are tethered. We are falling.
But the local group is not the end of the map. If we zoom out even further, our entire neighborhood, the Milky Way, Andromeda and the dwarfs, is just a tiny suburb on the edge of a massive city called the Virgo supercluster. This cluster contains thousands of galaxies, and even that is just a branch of a river. We recently learned that our supercluster is flowing like water toward a mysterious gravitational anomaly known as the Great Attractor, forming a structure immense beyond comprehension, Laniakea, the immeasurable heaven.
We are a speck orbiting a star in a galaxy, in a group, in a cluster, in a supercluster, drifting through the cosmic web. But let's return to our immediate danger. That blue giant Andromeda is getting bigger every night. It is not just a neighbor. It is our destiny. What happens when 2 cities of stars moving at bullet speeds crash into each other? The answer is not destruction. It is a new beginning.
New worlds. For thousands of years, we looked up at the stars and asked a single haunting question. Are we alone? We knew the stars were suns like our own. But did they have families? Did they have planets? Or was our solar system a cosmic accident? A unique miracle in a lonely universe? For a long time, the answer was silence. We had no proof.
But in 1995, everything changed. Astronomers pointed their telescopes at a star named 51 Pegasi and found something that shouldn't exist. They found a planet, but it wasn't like Earth. It was a gas giant like Jupiter, but it was orbiting its star closer than Mercury. It was roasting a hot Jupiter. This discovery shattered our understanding of planetary formation. It taught us that the galaxy is wilder than we imagined. We have launched hunters into the void. The most famous was the Kepler Space Telescope. Kepler stared at a single patch of the sky for years, unblinking. It was looking for a wink. When a planet passes in front of its star, it blocks a tiny fraction of the light. The star dims for a few hours. This is called a transit. By measuring this tiny dip in brightness, we can determine the planet's size, its orbit, and even its atmosphere. Thanks to Kepler, we now know the truth. Planets are everywhere. On average, every star you see in the night sky has at least one planet. There are more planets in the Milky Way than there are stars. And what a zoo we have found. The variety is staggering. We have found worlds that make science fiction look boring. There is HD 1819 and 33b from space. It looks like a beautiful deep blue marble, just like Earth. But do not be fooled, it is a hellscape. The wind blows at 8,000 kilometers per hour. And that blue color, it's not water. It is raining molten glass sideways in a supersonic hurricane.
We have found 55 concrete. Super Earth, twice the size of our planet.
But it is rich in carbon under the intense pressure of its star. Scientists believe the interior of this planet is made of pure diamond. A world of diamond, floating in the dark. We have found water worlds, planets entirely covered by oceans hundreds of kilometers deep with no land in sight. We have found rogue planets, orphans that were kicked out of their solar systems. They drift alone in the eternal darkness of interstellar space, frozen and silent, without a sun to warm them. There may be billions of these lonely wanderers passing through the dark matter halo. The holy grail of this hunt is not a monster. It is a mirror. We are looking for Earth 2.0. We are looking for a rocky planet the size of Earth orbiting in the habitable zone. The Goldilocks zone. Not too close to the fire, not too far in the ice. Just right for liquid water to exist on the surface. We have found promising candidates. Look at the TRAPPIST-1 system, just 40 light years away. It is a red dwarf star, much smaller than the sun, but packed around it are 7 Earth-sized planets. 3 of them are in the habitable zone. If you stood on the surface of one of these worlds, the other planets would hang in the sky, huge and detailed like terrestrial moons. You could see the clouds on a neighboring world with your naked eye.
The numbers are dizzying. Based on Kepler's data, astronomers estimate that there could be as many as 40 billion Earth-sized planets orbiting in the habitable zones of sun-like and red dwarf stars in the Milky Way alone. 40 billion potential homes, 40 billion petri dishes waiting for life. This leads us to the most disturbing paradox of all. If the galaxy is so old, if planets are so common, if life is just chemistry, where is everyone? This is the Fermi paradox. We have been listening with radio telescopes for decades. We have scanned the stars for signals, but all we hear is the static hiss of cosmic background radiation, the great silence. Are we the first? Are we the last? Or are we just not listening on the right frequency? Perhaps civilizations rise, build great technologies, and then destroy themselves before they can reach the stars. Perhaps the silence is a warning. But we are still young. We have only just opened our eyes. The galaxy is vast and our search has only just begun. But while we look for a new home, our old home and our entire galaxy is heading toward a date with destiny. A collision is coming. A collision that will reshape the heavens themselves. Great collision. We have explored the history of our galaxy. We have seen its birth, its structure, and its hidden monsters. But nothing lasts forever. Even a structure as colossal as the Milky Way has an expiration date. The greatest event in the history of our galaxy is not in the past. It is in the future. Remember the neighbor we saw in the darkness, Andromeda. While all other galaxies are rushing away from us due to the expansion of the universe, Andromeda is rushing towards us. It is closing the gap at a speed of 110 kilometers per second. Every hour that passes, it gets 400,000 kilometers closer. It is not a question of if, it is a question of when. About 4 billion years from now, the view from Earth will be the most spectacular sight in the cosmos. If humans, or whatever comes after us, are still here to look up, they will not see a calm night sky. Andromeda will no longer be a small fuzz in the distance. It will stretch across the entire horizon. Its spiral arms, glowing with billions of stars, will fill the sky, interlacing with the Milky Way's own band. The night will be brighter than the full moon, two immense cities of light, suspended in a gravitational embrace. First contact will happen. But this is not like a car crash. It is a slow-motion dance that lasts for millions of years. When the galaxies touch, gravity will go wild. The beautiful spiral arms of both galaxies will be distorted and ripped apart. Massive tidal tails, long streamers of stars and gas will be flung out into the void, creating chaotic, twisting shapes in the heavens. The gas clouds of both galaxies will slam into each other. This impact will wake up the sleeping nebula starburst. The sky will be set on fire with the birth of millions of new stars at once. It will be a celestial fireworks display of unimaginable proportions. Supernovas will go off like firecrackers, lighting up the chaotic sky. But here is the most surprising fact about this collision. Despite the violence, despite the chaos, almost no stars will actually collide. This seems impossible, but we must remember the scale of space. Stars are very small compared to the distances between them. Imagine the sun is a ping-pong ball in Paris. The nearest star, Proxima Centauri, would be another ping-pong ball in Berlin. Even if you throw two continents full of ping-pong balls at each other, the chances of two balls hitting in mid-air are practically zero. The solar systems will survive. They will just be tossed around. Our own sun might be flung out into the cold halo of the new galaxy, or it might be pulled into the chaotic center. But the Earth, if it hasn't been swallowed by the sun's own expansion, will likely be safe, enjoying a front row seat to the merger. Over the next 2 billion years, the two galaxies will pass through each other, drift apart, stop, and fall back together again. They will merge, mix, and settle. The beautiful spiral shapes will be gone forever. The arms will vanish. The rotation will stabilize. The result will be a single, gigantic, football-shaped blob of stars. A giant elliptical galaxy. Astronomers have already given a name to this future child of the collision: Milkdromeda. And deep in the heart of Milkdromeda, the two monsters will meet. The supermassive black hole of the Milky Way and the supermassive black hole of Andromeda will spiral towards each other. When they merge, they will release a blast of gravitational waves so powerful that it will ripple through the fabric of space-time of the entire observable universe. By the time the dust settles, 7 billion years from now, the sky will be very different. It will be a calm, golden haze of aging stars. The era of star birth will be mostly over. The gas will be used up. Milkdromeda will be a quiet retirement home for the survivors of the crash. The sun will likely be a fading white dwarf by then, drifting in this vast new empire. This is the ultimate destiny of our home. We are not static. We are fluid. We are part of a flowing, evolving river that is heading towards a magnificent waterfall. But even this merger is not the end of the story, because eventually, the stars themselves will go out. And that brings us to our final chapter: the legacy of consciousness in a dying universe.
Cosmic perspective
we have traveled a long way together. We started our journey on a small rock orbiting a yellow star. We climbed the pillars of creation, dived into the hearts of dying giants, surfed on spiral arms, and stared into the abyss of black holes. We have seen the invisible skeleton of the cosmos and predicted the fiery collision of our future. But now, at the end of the road, we must return to the most important question of all. The question we asked at the very beginning. What are we? In the scale of the Milky Way, we are nothing. If the history of the universe were compressed into a single calendar year, with the Big Bang on January 1st, the Milky Way formed in May. Our sun was born in August. The first life appeared in September. The dinosaurs died on December 30th. And all of human history, every king, every war, every invention, every love story, happened in the last 10 seconds of December 31st. We are a flash in the pan, a momentary spark in the dark. Furthermore, we know that this stage will not last forever. The era of starlight we live in is temporary billions of years from now. The fuel will run out. The last supernovas will explode. The white dwarfs will fade. The red dwarfs will flicker and die. The galaxies will go dark. The universe will become a cold, dark, and empty place, dominated by black holes and radiation. Entropy will win. It is the inescapable fate of thermodynamics. This realization could make us feel small. It could make us feel meaningless. If the universe is so big and ends in darkness, what is the point? But there is another way to look at it, a perspective that empowers us. Think about the odds. Out of the chaos of the Big Bang, atoms formed. Out of the cooling gas, stars ignited. Out of the dead ashes of those stars, carbon, oxygen, and iron were forged. And out of that stardust, against all statistical probability, you emerged. We are the only part of the universe that can think. We are the only part that can feel. We are the only part that can wonder. Without us, without life, the Milky Way would be just a heap of dumb rock and gas. It would be beautiful, yes, but there would be no one to appreciate it. It would be a masterpiece in an empty museum. We are the universe experiencing itself. We are the eyes through which the cosmos sees its own glory. We are the ears through which it hears its own music. Through our curiosity, the universe has woken up. So, look at that screen again. Look at that blue marble floating in the void. That is us. That is everything we have ever known. In this vast, violent, and indifferent galaxy, that tiny rock is the only sanctuary we have.
It is the only place where the universe is alive. We have no evidence that help is coming from elsewhere. There is no one coming to save us from ourselves. The walls of the galaxy are cold and far apart. The distances are insurmountable. For now, and perhaps forever, we are on our own. This gives us a profound responsibility. We are the custodians of life. We are the keepers of the flame of consciousness. It means we must cherish this fragile home. It means we must stop fighting over imaginary lines on a map and start acting like the crew of a spaceship. Because that is what we are. We are travelers on a natural spaceship called Earth, drifting through the Orion, arm of the Milky Way. The journey of discovery is not over. It has just begun. There are billions of worlds left to map, trillions of stories left to tell. The silver river flows on, carrying us into the unknown. So, tonight, when you step outside, don't just look up. Look out. Feel the rotation of the earth under your feet. Feel the gravity of the sun pulling you. Feel the silent spin of the galaxy around you. You are not separated from this. You are not an observer looking at the universe. You are the universe. You are stardust that has learned to dream.